Now, when we talk about the relationship between the frequency and the wavelength, we got to think about what happens. And we've seen this when you were learning about the electromagnetic spectrum, that as the frequency increases, the wavelength decreased. And if we show that on a graph, and we put frequency over here, as the frequency gets bigger, the wavelength gets smaller, okay? And so as we go this way on the graph, the wavelength is going to go down, so it's going to look like this, like that, okay? So on a frequency versus a wavelength graph, that's what it's going to look like. As the frequency gets bigger, the wavelength gets smaller, but this is only true if the wave speed stays constant. So what that looks like in formulas that we can use to do some math is this. We have the wave speed, which is just a v, just like any old speed, is f times lambda. Or if we need to find the wave frequency, it's the speed divided by the wavelength. Or if we need to find the wavelength, it's the speed divided by the frequency. And so when we look at what that means when we're thinking about stuff, which should be familiar from the electromagnetic spectrum, if it has a high frequency, it has a short wavelength, so that means there'll be a lot of waves in 1 second, but they'll be really tiny like this, okay? Which you saw perhaps drawn somewhere, or if it's a low frequency wave, it'll have a long wavelength, and so you'll have very few waves in 1 second, so they'll be stretched out more like this. And that's what it looks like on your electromagnetic spectrum chart that you had in your notes.